Good day, everyone, and welcome to another problem-solving session with Special Maths Academy. So we'll be discussing the next number theory problem in the series. That is number 43 from the just concluded Nigerian Mathematics Olympiad, the first round for the senior category. Okay, so let P be a prime, and let A, B, C, D be integers such that P divides AB minus 1. Okay. P divides B plus C, and P divides CD plus 1. Okay. So now, looking at this first division and the last division, what do we have? Let's look at the implication of what it means for P to divide AB minus 1. So it means AB minus 1 is equal to some, let's say, MP, some integer M. So it means AB minus MP is equal to 1. And this implies that the GCD of, so again, when I say GCD, I mean the highest common factor. The GCD of A and P is equal to the GCD of B and P is equal to 1. And a similar scenario for CD plus 1. You can say let it be equal to NP. And so we have CD minus NP equal to minus 1. And the reason why I say GCD, because if the GCD of A and P must divide AB and must divide MP, so it must divide 1. So it has to be 1. And similarly, we can get that the GCD of A and C is the same thing as the GCD of A and D, and is equal to 1. Okay, so we can keep that aside. Now, looking at the first and the second again, still the first and the last. Now we can add the two divisors. So it implies P divides AB minus 1 plus CD plus 1. And this is the same thing as P divides AB plus CD. Okay. Now looking at the P dividing B plus C. So now since the GCD of P and B is sorry, this should be A. This should be P and C. So sorry about that. And P and D. Okay, so since the GCD of P and B and the GCD of P and C are both equal to 1, we have that from P divides B plus C, we have that P does not divide B and P does not divide C. Okay, so it means P does not divide B minus C. Okay. Unless B minus C is equal to 0. Okay, so now let's manipulate P dividing B plus C. So P divides B plus C. We can say this implies P divides B plus C into A plus D. And when we expand this out, we have P divides AB plus BD plus AC plus CD. Okay. So this is equivalent to P divides AB plus CD plus BD plus AC. Okay. Now we see that we have AB plus CD here, and we have AB plus CD here. So we can manipulate this to get some more things that P can divide. So it means P divides, so let's read this. AB plus CD plus BD plus AC minus, so let's put this, minus 2 into AB plus CD. And we can do this because we already have that P divides AB plus CD. So this is equivalent to, so I'll just erase this. Okay. Okay. So this is equivalent to P dividing, so this will just change to minus. So we have a minus AB minus CD plus BD plus AC. Okay. So we have P divides, so we can try and factorize this. So we have a D into, so we can just put this negative sign here. So we take this guy and this guy. So I have B into A minus D. Okay, and then we have C into, so I have A minus D. So taking this guy and this guy. So we can factorize that to have that P divides negative B minus C into A minus D, and factorize this. So now we show that P does not divide B and P does not divide C, and hence P does not divide B minus C unless B minus C is equal to 0. And if B minus C is equal to 0, then it will mean that P dividing B plus C is equivalent to P dividing 2B. So we have two cases now. If P is even, either P is even, so this will force P to be even, because in that case we implied P divides B, which we've already countered from here, that the GCD is 1. Okay. So now if P is 2, we'll consider that case later. But if P does not divide B minus C, we have that surely P must divide A minus D. Okay. So if P is even, if P is 2, I will imply that AB minus 1 must be even. So AB must be odd. So this has to be odd if P is 2, and CD has to be odd. So it means they'll all be odd integers, and still P will divide A minus D. So in both scenarios, this is surely true. So P divides A minus D, and hence our answer is option C. Okay. So that'll be all for this video. See you guys in the next video. Till then, keep solving maths. Don't forget to like, comment, share, and subscribe. Goodbye, guys.